Now we're going to move on to chapter 2, more about quadratic equations. We have already learned about quadratic equations in Sec 2 syllabus. So let's do a quick recap on what is a quadratic equation and what did we learn how to handle a quadratic equations in Sec 2. So first of all, how does a quadratic equation look like? You need to know the general formula for the general equation. The general equation will be y equals to ax squared plus bx plus c. Okay, of course it's not restricted to x. So for example, if you have something that looks like 4a squared minus 2a plus 3 equals to 7. Now this itself is a quadratic equation because the highest power here is your a square, is your square, right, of power 2, and there is no other variables other than an a. So this will be a quadratic equation. And what do we learn about quadratic equation in Sec 2, or how do we handle a quadratic equation, the kind of questions that you will get? So last year, you learned how to handle a factorized question. How do you factorize a quadratic equation? So suppose if you have an equation that looks like this, say x squared minus 1, and you are supposed to factorize this. How do we do this? X squared minus 1. This is in the form of a squared minus b squared, and therefore you should have a minus b, a plus b. Okay, so this one you just really you have to memorize this by now. So you will have, and if you've forgotten, you have to pick it up again. You should have x minus 1, x plus 1. Okay, so this is one method of factorization on how to factorize a quadratic equation that you have learned. And then the other way would be your cross method, okay, or the table, depending on what you learn in school. But for my own students, I taught them this table here. Okay, so over here, suppose y is equal to 0, so your equation will be this. When you factorize, you will put your x squared here, negative 6x, and 9. Okay, so when you factorize, you will get this. So 0 is equals to x minus 3, x minus 3. Okay, so in the factorized question, you will just stop here. Okay, so this you have completed. Up until this step is what we call factorization. And then after that you learn how to solve an equation where you'll be told what y is, or you can deduce from the question what y is, and then you go ahead and solve. So this whole portion here will be solve for x. Solving for x, okay, or you solve the equation. So over here, when x minus 3 is equal to 0, so therefore either this bracket equals 0 or this bracket equals to 0, but in this case both brackets are the same, so x equals to 3. So this is what you have learned. You have learned to factorize and solve a quadratic equation. And in Sec 3 now, for this chapter, you are going to learn 4 methods to solve quadratic equation. So the first method that you're going to learn will be by factorization, which you have more or less learned last year. And after that, you're going to learn graphical method. You are going to learn how to complete the square method. And lastly, the quadratic formula. So these will be the 4 methods that you will learn to solve a quadratic equation. So today we're going to focus on factorization. So what did we learn about factorization in Sec 2? So we learned that if we are given two terms, for example, 25 minus x squared, how do we factorize it? In this case, you can't use the cross method. So you have to go back to the 3 special formulas that you have learned, and this will be one of them, where you can use 5 minus x, 5 plus x. Okay, and let's recap again. This is the formula of a squared minus b squared, which gives you a plus b, a minus b. Now this is the factorized form, meaning you should put them back into brackets. This is the expanded form. So it has been expanded. After expansion, there's no more brackets left. So this is one factorization that you have learned if you are given 2 terms. And if you are given 3 terms, for example, in the case of just now as we mentioned, this one, then you can go back to this cross method. Okay, so this is not too difficult. And if you're given 4 terms, for example, pq plus q, 6p plus 2. For example, if you're given 4 terms, 3pq plus q plus 6p plus 2, then in this case, okay, please take note, this is not a quadratic equation, but this is what you had learned to factorize last year. So this is factorization by grouping. So how do you group them? First of all, look at these first 2 terms. The common factor here is q, which you can factorize out, and you're going to left with 3p plus 1. And the last 2 terms, the common factor will be 2, and when you factorize out, you're still going to get 3p plus 1. Now, we can factorize out 3p plus 1 over here, because that is the common factor. You can see the bracket as a number, so this is just a common factor, and then we factorize out, and what is left is q plus 2. So these are the 3 things that we learned about factorization last year. So for this year, 2.1 factorization method, you shouldn't have an issue here unless you have some careless mistakes. So first of all, in try it 2, you're asked to solve this equation, and we need to first make sure that one side must be equal to 0. So to solve by factorization method, first of all, please take note that one side of the equation must be equal to 0. Okay, so this is because of the 0 factor error, meaning once you factorize and it's equal to 0, then either you can confirm that this bracket is equal to 0 or this bracket is equal to 0. Otherwise, there's no way we can find out or assume about the 2 brackets. So first of all, solve this. Let's just expand this side first. Okay, so 9x squared minus 18x minus x plus 2 is equal to negative 7x minus 2. So let's move all to one side first. So make sure that one side must always be equal to 0. So there we have it. Now the next step would be to factorize the 3 terms here. Okay, we have a quadratic equation now. So factorize 9x squared minus 12x plus 4. You can deal with this cross method or the table that your teacher taught you. So this comes with a bit of experience or try and error. So I'm just going to try 3x and 2 and 2. Okay, that means this is 3x minus 2. This is what you want eventually. So 3x minus 2 equals to 0. And therefore, what we can conclude is this bracket is either equal to 0 or this bracket equals 0. But since both are the same, we can safely assume that 3x minus 2 is equal to 0, and therefore x is equal to 2/3. And there we have it. We have solved this equation. For try 3, solve this equation. This question is slightly different from the previous question. Why? Because we can obviously see that there's a common term. There is no problem if you want to do like the previous question, meaning you expand everything out, move all to one side equals to 0, and then factorize. But it will be easier for this question to make use of this common bracket. So I'm going to shift the term over first. Always make sure that one side is equal to 0. Now this is the common term. So this looks a bit like the This looks a bit like the factorization by grouping, except that you have already come to this stage. You can now factorize out this 5x plus 3, and then you are left with 2x minus 9. So in exam, it will be much more time consuming to expand everything, put all to one side, make sure it equals 0. It's faster if you can just see that, okay, they have a common factor, which is 5x plus 3, and I can just factorize them out. And now I can assume that this is equal to 0 or this is equal to 0 by your zero factor theorem. So I will have 5x equals to negative 3, 2x equals to 9. Please do remember, right, this or is very, very important. There we have it. X is either this or this. These are the two possible values that x can be. So let's move on to level 3, question 3. The sum of areas of two squares is 269, and one side of a square is 3 cm longer than the other. So find the length. So obviously you have to form a quadratic equation to solve this. You have one unknown, which is x. As long as you can form one equation, you are able to solve it. So the sum of the areas of two squares. Now this area is x squared, and this area here is x plus 3 squared. So that means these two areas together, they give you a combined area of 269. So by looking at this, you know that you can form a quadratic equation. Now you're supposed to expand this a squared plus 2ab plus b squared. I hope you still remember. So we simplify. Please remember one side must be equal to 0. Since this is all even number, we can simplify it further. Let's just divide by 2 across. Now it makes it slightly easier. 0 divided by 2 is still 0. And then this I can plot into my table. Alright. So what you have is x plus 13. This is what you want. And x minus 10. So therefore, because it is equal to 0, I can safely assume that either this bracket equals to 0 or this bracket equals to 0. So x is equal to negative 13 or x is equal to 10. Now, why do I say that it has to be equal to 0? Now, if a times b equals 0, then definitely either a equals 0 or b equals to 0. But suppose you have one side of the equation where it's not equal to 0. Any number, it can be 1. So there's many possibilities what a can be. A can be equals to 1 or b equals to 1, a equals to negative 1, b equals to negative 1, and b equals to negative 1, both. Okay, or a equals to 2 and b equals to half. So there's so many combinations you cannot pinpoint which is which. So it's not a good idea to try to solve that quadratic equation as long as the other side is not equal to 0. So please always make sure that one side is always equal to 0. That is where most errors come from. So for this chapter, although it is simple, please make sure that you understand zero factor theorem and how it works and why it has to be equal to 0.